Okay, this is still development of a solution to example one for CS3 for fall 2025. A pickup of demo where we were in class. And I think I've got everything about to where it was before. Let me review. We've got three files that we're using for example one so far. The stack.h to declare the stack class, stack.cpp to implement it even though there are nothing but stub functions so far, and the example1.cpp. And to make sure I haven't lost ground moving to my office, I'm going to run it again just to make sure. Get some blank space, up arrow to get to the compile to make sure I'm using the most recent versions. Only the CPP files, not the H files. And then when you want to run it and you did not specify an output file, it always goes to a file named a.out. Pushing words, pushing my luck. And I don't know if those are going in there or not. So I'm leaving all these windows open and just swapping back and forth among them. I'm going to change my luck to my luck because the way it was set up in, I think, at least in the examples in example one project description, they were all one word. So this way it's all one word. Words, my luck, print debug. I think the next logical step is going to be for me to do something to implement push because print debug, there's nothing to print if push is not putting anything in there. So I don't know where I'm going with all these clicks. How about stack.cpp and work on the push? And of course I don't have the picture here, but I do know that what? I don't need to test top. Oh, I do need to set an initial value for top. And to do that, I'm going to need a constructor. I'm eventually going to need a constructor and destructor, but this will be called, I believe the constructor is just called stack, S-T-A-C-K, and it doesn't take any parameters. There's nothing to pass in because you're just making a brand new stack variable. And I might as well, while I'm at it, make a destructor. The squiggle, where is that on my keyboard? You'd think after all these years I would know. Tilde stack is the destructor, which initially won't have anything in it, but as I'm sure you can see on the horizon, since we will be doing dynamic memory allocation of nodes to put in the stack, we will have a mess to clean up when we're done. Now then, there's no reason really to copy and paste those, but I need to put in constructor and destructor. I'll start to comment a little better. Constructor, destructor. And then I realized, no, I don't want to put in a bunch of comments now because that's going to slow things down and I want to speed things up. This is going to be the stack, colon, stack function, because that's just how it works in C++. And all of that effort was so that I could set top to an initial value of 0. Some of you have already been using null pointer, and that's defined in some C++ implementations, but not in others. Every C++ knows what a 0 is. And push and pop, let's see. Now I think I can do push. Push, I will definitely need a new node for the new thing that's being pushed. Node star, I'll just call it new node, equals, and make a new one, new node. Or so I'm going to claim. This, let me see. I do need that, but it's going to be the new top. You know, I'm going to try to come up with better variable names. Excuse me while I work on this. New top. This is going to be the new top of the stack. So the new top equals the new node, and it's going to have the new value in it. New top, arrow, and I don't think I called it data. I think I called it value. I can check. I've got all these files open. That's a handy part of having tabs here in Sublime. It's called value, just plain old value, equals new value. Look how intuitive those variable names are after I finally figure out what they are. So now I've got the new node, and I'm ready to make it the new top one. So I need to say new top, arrow, next, equals top. I'm trying to draw the picture in my mind that we had on the board. that that is that it? New top next equals top. No, that's not it. I need to set top equal to new top. This might not have been the most efficient way to go about this, but I'll test it and see whether or not it works. Top equals new top. Let me look through this again. I made a new node that a temporary pointer called new top points at. I set the new node's value to the new value that was just now passed in, and I set the next pointer to the old top, and now I'm ready to set the top of the whole thing. Now notice these are even different colors, thank goodness. Top is a different color than new top, and I don't know that the reason is, but it could be that top, no, I was going to say it's because top is a private variable and I didn't declare it here, but that's not it because, okay, scratch all that. My brain can't be fried this early in the day. There's push. We'll say that's push. And I might as well get a print debug because I'm not going to be able to detect anything until we do print debug. And print debug ought to be an accessor, come to think of it. So I'm going to say const out here, which means that print debug does not have the power to change any of the values of any of the private variables. It should not. Taking a look at what's already in the stack, that act itself should not change the contents of the stack. So to be able to march through the stack, I'm going to need a temporary node pointer. Node, and I will call this one temp. It's going to temporarily be each different node in the stack. So I need to keep looping while temp. And you might recall from class, I hope you do, that this is testing to see if temp is equal to 0. So if I just copied a 0 in there because there's nothing there at all, then the while loop is going to fall out immediately and there's no work to do. If temp is not 0, then I need to do a couple of things. I need to see out the value of temp and probably a blank to separate it from the next thing. And I'm going to keep it on the same line. I'm not going to do an inline here. But I also need to certainly remember to go to the next node. Temp equals temp arrow next. No. Temp equals temp arrow next. Come on, caffeine. Help me here. I need to label this. And it's a debug function, so any label I put is my own business. See out current stack contents. And I'll keep that on the same line. So it won't go to the next line until it's printed out everything on the stack, and here I'll put an inline. This is an awful lot of typing without any testing. But maybe now I have an actionable push function and also a working print debug function, at least something that maybe will compile and run. And I don't remember if I've updated all the prototypes or not. But I'm going to do a print debug before and after. Actually, I'll do a print debug a lot. Why not? Because I need to see what's in the stack to see if this is working correctly. I'll do it before I do anything else. And on this editor, at least, I can just choose print debug. And pushing words, I pushed words. Let's try it again. S.print debug. And already it's looking ugly. So there. Now it should try to print something in the stack and then push words, and then it tries to print the stack then. Well, you can see what it's supposed to be doing. And Command S to save everything. Now I can see it, thank goodness. So I can just go to File. Is there a Save All? Save All. There's no way I'm going to remember those hotkeys, and they're probably different in the lab anyway, so they wouldn't be of any use to you. Now, finally, back to the console window. Nope. It can't find something. The linker can't find the it can't find the destructor. Even though the destructor doesn't do anything yet, I still got to have it. So the destructor is the squiggle stack void function. And it's even though it's not called to last, it's conventional to put it up here with the constructor. Stack, it's got to be a stack member function, but this one's called squiggle stack for destructor. It's also void. And it doesn't have to have a darn thing in it. So now at least I have a stack destructor, and that should make the linker happy. So let's try the Command S again, and back to the console, and space, up arrow, there we go, and run it with slash a.out, /a.out. Current stack contents. Whoa, those are pointer values. That's no good. My print debug needs some work, apparently. But it does have one node and then two nodes. Good for that. Let me see. For one thing, I was going to change this. There. And the print debug. You are a problem. Oh, look how stupid I am. Well, you already knew that. Cout temp, that is a pointer. That's a pointer to a node. Oh, I wish I could say I meant to do that. So you could see what happens when you try to print out a pointer value. That was printing out the addresses of our two nodes in the stack. I need to print out temp arrow value, which will be the value that will be saved inside the node, inside the stack, inside the program, on a hole in the bottom of the C. So Command S to save everything again. Console. Run. No, don't run yet. No. Compile first. Now. /, that's not a command. A.out. Look at this. Look at this. Current stack contents, nothing. I pushed words. Current stack contents, words. Pushing my luck. You're telling me. It looks like I didn't save the main program. I thought I fixed that string. It's supposed to be all one word. And it's got my luck and words. So that is, my luck is at the top of the stack and words is at the bottom of the stack. So it's doing what we're asking it to do. Oh, I didn't save all. That's what the problem is. File, save all. Talk about mother, may I? Let me try this again. Compile, please. Run, please. Okay, now that's the output I was looking for, even though I need some blank lines in there to separate stuff. You know what? That's a working push function, or at least it appears to be, and a working print debug. So I'm not going to push my luck any further. I'm going to stop this video and do another one for the pop operation. So this is how you do push. Halt.